Today, we are going to check the revision on 2023 Waec that just passed. This will enable you, this will help you to face the coming one that you're about to write, which is the chemistry, and the subject is basically on chemistry. Now, let's go to number one. Number one says, which of the following laws or theory cannot be explained by the application of the kinetic theory of gases? The kinetic theory of gases talks about the movement of gases based on how temperature affects the movement of gases. Now, looking at the options, the Dalton's atomic theory talks about the theory of the existence of atoms. Okay, the theory of the existence of atoms. Now, it does not have anything to do with gases. The Charles law explains the gases as the temperature increases, the volume reduces. As the temperature increases, the volume decreases. The Gay-Lussac's law talks about how gases combine in simple whole ratios. How they combine, how the volume of gases combine in simple whole ratios. While the Boyle's law tells us that as the pressure increases, the volume increases. So the B, C, and D basically talks about the theory of gases, while the A, which is the Dalton's atomic theory, talks about the existence of atoms. The Dalton's atomic theory talks about the existence of atoms. So the right answer is A. The next one says the primary component of natural gas. When you say natural gas, they're talking about the hydrocarbons, the crude oil, petroleum products. Now, the primary component, that means the first gas that comes out, is your methane. Your methane is LPG, although they are all from the alkanes family. The butane, the ethane, the methane, the propane are all from the alkanes family. Now, the alkane is the simplest form of hydrocarbon. The alkane is the simplest form of hydrocarbon in the alkane, alkane, alkyne, and alkanol. And it has a single bond when bonding with carbon. Forms a single bond when bonding with carbon. Now, the butane is not a primary gas. It comes out after methane. We have butane, we have propane, then we have ethane. So the correct answer is methane, since the primary means the first gas that comes out from hydrocarbon. So the correct answer is C, which is methane. The next one is thermal cracking of alkanes usually. Thermal cracking of alkanes usually, they say, involves decomposition. A. 2 is an exothermic process. C. produces only small alkanes. And D. requires hydrogen. Now, it involves decomposition. When they say thermal cracking, they're talking about breaking down with heat. Cracking is just to break down. Thermal there is heat. So using heat to break down alkanes. Now, when heat is added on a substance, that substance must have to decompose. In essence, it must have to expand, and it must have to decompose. Now, when they say it involves decomposition, meaning it must be scattered. Okay, thermal cracking of alkanes the alkanes must be scattered. So it involves decomposition. Why the B says is an exothermic process. An exothermic process is a process where the system loses heat. If they had put in endothermic process, that too would have been the answer, because before something to decompose, heat must be gained. The system must absorb heat, and that process is endothermic process, where a system absorbs heat. Okay, the endothermic process, the exothermic process is when the system loses heat. So it involves decomposition, because when a system absorbs heat, that system must have to face decomposition. It must have to decompose because of the application of heat. So the correct answer is A. The next one is number 4. Carbon is deposited in the exhaust pipes of cars because A. Contamination of petrol with diesel, presence of carbon in petrol, presence of additives in petrol, incomplete combustion of petrol. Now, the contamination of petrol with diesel is a no-go area. Okay, that means you're mixing diesel and petrol. I think they're miscible liquids. Miscible liquids are liquids that can mix. That's not a reason anyway. So presence of carbon in petrol, although carbon is present in petrol because it is gotten from hydrocarbons. All right, petrol is gotten from hydrocarbons, gotten from petroleum, and every petroleum product it contains hydrocarbon. All right, because it has hydrogen and the carbon. So that's why petroleums are called hydrocarbon. And we know that petrol is a petroleum product. It contains carbon, yes, but when cars undergo full combustion, they produce carbon dioxide. That means to say carbon forms two oxides, right? Carbon dioxide and carbon monoxide. Carbon dioxide and carbon monoxide. Now, the carbon monoxide is based on incomplete combustion, while the carbon dioxide or carbon dioxide is based on complete combustion. What do I mean? Carbon exists in air as carbon dioxide. It's just like when we are eating, okay? Our food digestion will give us energy. Our food digestion, when food is digested properly, it gives energy. And in that context, we send out carbon dioxide because there was a complete digestion. So the cars too have to digest the petrol. That's the combustion they're talking about. Combustion is just burning, actually. So when this carbon undergoes full combustion, full burning, full usage, then it brings out carbon dioxide. But since it does not undergo full usage or full combustion, it must have to bring out an incomplete combustion of petrol. So carbon is deposited in the exhaust pipes of cars because of incomplete combustion of petrol. Number 5. How many moles of copper would be deposited by passing 1 Faraday of electricity through copper chloride solution? Through copper chloride solution. Now, that means the chlorine there is a liquid, and the copper there is a metal. For a solution to occur, all right? For a solution to occur, there must have to be a solute and the solvent. So that means the copper is the solute and the chlorine is the solvent. So they say how many moles of copper would be deposited by passing 1 Faraday of electricity through a copper chloride solution. Now, 1 Faraday is equals to 1 mole. 1 Faraday is equals to 1 mole. And 1 Faraday is 96,485 coulomb. 96,485 coulomb. So that means this 96,485 coulomb is equals to 1 mole. All right? And they say how many moles of copper would be deposited by passing 1 Faraday of electricity through copper 2 chloride. Now, the copper 2 chloride ions, definitely, since the copper 2 chloride. So since the copper is 2, that means 1 Faraday will be equals to 2 electrons of copper. That means 1 Faraday will be equal to 2 electrons of copper. So that means if they say how many will be deposited by passing 1 Faraday of electricity through these 2 electrons of copper. Through these 2 electrons of copper. So that means since there are 2 electrons, all right, so sharing the 2 electrons into 2, that means it is going to be 0.5 moles. Sharing these 2 electrons into 2, because it is 1 Faraday that is passing. So the 1 Faraday passing through 2 electrons must have to be shared into 2, because the 1 Faraday will be divided by 2. So it's going to be 1 over what? 2. The 1 Faraday, the Faraday divided by the number of moles, which is the 1 Faraday divided by the mole is 1/2, which is 0.5 moles. So the correct answer is C, 0.5 moles. Alkanes can be manufactured by addition of hydrogen to unsaturated vegetable oils, the cracking of hydrocarbons, polymerization reactions, and the combustion of alkanes. Now, I told you previously just now that hydrocarbon has 3 families. It's shared into 3, which is the alkanes, the alkanes, the alkynes. All right? So every cracking will produce, it's like the hydrocarbon is a father giving birth to these alkanes, alkanes, and alkynes. The hydrocarbon is the father giving birth to these alkanes, alkanes, and alkynes. All right? Now, addition of hydrogen into unsaturated vegetable oil. Unsaturated vegetable oils are things that vegetable oils that do not dissolve in a solvent completely. Do not dissolve in a solvent completely. In essence, tend to make that particular mixture an unsaturated solution. All right? So the mixture becomes heterogeneous and the solution becomes unsaturated. So when you put hydrogen to unsaturated vegetable oils, alkanes is not being produced. So they say combustion of alkanes. Combustion of alkanes cannot produce the alkanes. Why? Because the alkanes is still a son of the hydrocarbon. It's like telling me that a father, okay, will give birth to his brother. That's what it means. So that means since he cannot, okay, we check the cracking of hydrocarbons. It is the father that will crack himself out and give birth to children. Now, cracking is a chemical process in which larger hydrocarbons are broken down into smaller or more useful ones. Cracking is a chemical process in which larger hydrocarbons are broken down to smaller ones or more useful ones. So the hydrocarbons, when you break hydrocarbons down, we have alkane, alkane, alkynes, and alkanols. Okay, so that means the number 6 answer is B, the cracking of hydrocarbon. The next one says petrochemistry is an example of. Petrochemistry is not pure chemistry. All right? It's not even environmental chemistry. Environmental chemistry it talks about those pollutions and so on. Biochemistry talks about the human system. All right? And so on. The pure chemistry talks about the physical chemistry, about matter and so on. So petrochemistry is chemistry of hydrocarbons, all right, of petroleum, of thermal crackings and so on. So it was applied into chemistry. Okay? It's not a pure chemistry. It's something that is applied, that is added to chemistry. So the correct answer is B, is an applied chemistry. Species that occur in a reaction, that's number 8, species that occur in a reaction pathway but not in the overall reaction are known as products are formed after a reaction. Products are formed after a reaction, not in between the reaction. Products are formed after a reaction, not in between the reaction. Okay? Now, inhibitors do not go in the reaction. The reactants are those things that undergo the reaction. All right? Reactants are those species that undergo the reaction. In essence, they have a complete reaction to form the product after the reaction. Now, intermediates, okay? Intermediates are what happens in the process of the reaction. Intermediates are those things that happens in the process of the reaction. Okay, they are being shown in the reaction when the reaction occurs. That means intermediates are chemical species that are formed during a reaction but not consumed before the final reaction. They are not consumed before the final reaction. Okay, they occur during the process of reaction, all right, but are not consumed before the final reaction. So the correct answer is D, intermediates. The next one is which of the following statement is correct? So the following statement is correct. It says an alkane with 49 carbon atoms contain 100 hydrogen atoms. B, addition reaction occur between alkanes and chlorine. C, butane has a lower boiling point than propane. And D, pentane have 5 isomers. You know, when they say butane has a lower boiling point than the propane, you know, it's after propane we get butane. So the higher the boiling point, the products occur. So as the products, petroleum fractions depend on the boiling point. All right. So as the boiling point is going, that's how different products or fractions are being gotten. So the product that comes after another has a higher boiling point than the one that is after that one. So let's see the A, option A. They said an alkane with 49 carbon atoms contain 100 hydrogen. Okay, an alkane with 49 atoms. The molecular formula for alkane is CnH2n plus 2. So the molecular formula for alkane. Now they say this alkane, this Cn talks about the number of carbons. This 2n talks about the number of hydrogen. So if they say it has 29 hydrogen, this n talks about numbers. So if they say it's hydrogen, you're going to times the hydrogen by the subscript that you see here in the molecular formula. So now this n identifies number of what? Carbon. So that means they say number of carbon is 49. All right? So the number of carbon is 49. So we have 49 plus, they say the amount is plus 2. Because the molecular formula says CnH2n plus 2. So anything you get here, you plus it 2. Anything you get here, you plus it 2. So if it's hydrogen, this n identifies number. You times the hydrogen by 2, then you plus by 2. But since they say it's carbon, all right, so it's going to be 49. So the number of carbon is 49 plus 2. 49 plus 2 is what? 98. All right? 49 plus 2 is 98. 49 plus 2 is 98. So the number of hydrogen atoms there is what? 2. So it will be plus 2, which is what? 100. Because you must have to get the mass of this particular alkane. And the mass of the alkane means adding everything you're seeing here. So the number of hydrogen is 2. Number of carbon is 98. All right? So it will be the 98. Now the 98 now is the number of carbons. The 98 is the number of carbons. Now we want to know the number of what? Hydrogen. Number of hydrogen, you just plus 2 to give you what? 100. So that means the A option is correct. That says that an alkane with 49 carbon contain 100 hydrogen atoms. So the correct answer is A. The next one, number 10, says the best indicator for the titration of ethanoic acid with sodium hydroxide is, the best indicator to use for the titration of ethanoic acid with sodium hydroxide is A, methyl orange. B, okay, methyl red A, methyl orange B, screened methyl orange is D. The answer is phenolphthalein. 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 Why? Because ethanoic acid is a weak acid. All right? And sodium hydroxide is a stronger acid. So the answer is phenolphthalein. phyllophthalein. So phyllophthalein has a pH of 32 or so. So number 11. Number 11. The reduction half equation of the following reaction is, reduction half of the following reaction is, now looking at the reaction, they say the zinc as a solid reacting with copper sulfate in aqueous solution. So it's N, solid, react with copper sulfate, aqueous, gives you zinc sulfate and copper solid. Zinc sulfate in aqueous solution. Now, an aqueous solution is a solution where the solvent is water. That means this zinc sulfate becomes a solute that is being dissolved in water. Now, checking the equation, you definitely see that copper was displaced, all right, in this reaction. Because for every reaction to occur, it must have to be A reacting with D and B reacting with C. This is A, B, C. All right? So this zinc must have to react with sulfur oxide and the copper will be displaced. Now when copper is displaced, you now see that copper accepted two cations. The copper already is a cation. Why? Because the copper is a metal. Every metal are donors. Why non-metals are acceptors. All right? The metals donate electrons and the non-metals accept electrons. So in this particular thing, you see that copper was displaced actually. So copper being displaced means it donates 2 electrons and accepted 2 electrons. So if you check the reaction, let's see where copper donated 2 electrons and accepted 2 electrons. Okay? The A is giving you that it is sulfide that did the donation and the acception. The B is showing us that it is copper that did the donating and the accepting. Okay, so if you check, the copper was in an aqueous solution, definitely gave out 2 electrons in the B reaction. So it is going to be Cu2 aqueous, all right, plus 2 E electrons given out is going to give us copper what? Solid. Going to give us copper solid. Well, if you check, like I said, the copper is being displaced. Now, him being displaced in the sulfide is 4. So it's going to accept 2 from sulfide and send out 2 as an electron. So the correct answer is B. Next one says, if 100 centimeter cube, okay, of a saturated solution of sodium tetraoxosulfate 6 at 30 degrees Celsius contains 10.5 grams of the salt, what will be its solubility at the temperature? Na subscript 2 SO subscript 4 is 142. So they've given you the molar mass of sodium tetraoxosulfate 6 as 142. As 142. It's a simple mathematics. Okay? It's a simple mathematics. So, let's solve. Now, they say the sodium is 142. So, Na to SO4 is equals to 142. The 142 becomes the mass number. That is what we are working with. Becomes the molar mass. All right? That's what we are working with. So, now, 100 centimeter cube of saturated solution of sodium hydroxide at 30 degrees Celsius. That means the constant temperature of 100 centimeter cube is 30. The constant temperature of 100 centimeter cube is 30. Is 30. So that means they've given you the constant temperature already. They've given you the constant temperature already. The constant temperature has been given to you already. All right? But if you still want to do, you can say 300 divided by 100. The temperature divided by the solution times 10.5 divided by 1,000. You're still going to get the same answer. You're still going to get the same answer. But we just have to give it a fast one. So when they give you the temperature, when they give you temperature, that temperature remains constant. All right? That temperature remains constant. So as long as the temperature is constant, you do not work with the temperature. All you need to do is to take the volume, the mass of the substance, and divide it by the molar mass. You take the mass of the substance and divide by the molar mass. Now the mass of the substance is 10.5. If you divide it by 142, 10.5 divided by 142, divided by 142 is giving us 0.738. All right, 0.738 approximately 0.74 mole decimeter cube. Mole decimeter cube. Mole decimeter cube. 0.74. 0.74. But if you still want to use that long way, we can be able to use the long way. All right. So using the long way is the volume, the temperature divided by the volume. Okay, the temperature divided by the volume times 1,000. It will be 30 divided by 100 times 1. Okay, 30 divided by 100. All right, so 30 divided by 100, it will give you 0.3. 0.03. 0.3. Divided by 100 will give you 0.3. All right, so the 0.3 times 1,000. All right, 0.3 times 1,000 is 300. So 300 divided by 142, you still get the same answer. So the answer is 0.74. Number 13. An example of a crystalline substance that does not possess water of crystallization is, does not possess water of crystallization is, when I say water of crystallization, crystallization is a separation technique. Okay, so potassium trioxynitrate, no, sodium tricarbonate. Sodium trioxocarbonate 4. Sodium trioxocarbonate 4. That's Na sodium trioxocarbonate 4. NaCO3. Sodium trioxocarbonate 4. Sodium trioxocarbonate 4 does not possess water of crystallization. The correct answer is B. Number 14 says a salt solution formed from a reaction between ethanoic acid and sodium hydroxide solution will be. Now, checking at this, looking at this acid base and salt, ethanoic acid is a weak acid, and sodium hydroxide solution, sodium hydroxide is a strong base. So that means the acid, the base will definitely oppress the acid. Now, when acid reacts with bases, it's called neutralization. When the base reacts with an acid, it's called neutralization. Why? Because the base neutralizes the acid to produce salt and water. The base neutralizes the acid to produce salt and water. So if the acid is a weak acid, of which ethanoic acid is a weak acid, the base will overpower and neutralize more than it is supposed to neutralize. So that means the base takes over the reaction. That will make the reaction a basic reaction. But if the acid is a strong acid reacting with a weak base, then the reaction will be acidic. But if there is a strong acid reacting with a strong base, that reaction will be neutral because they are both strong. So, but since the acid is a weak acid reacting with a strong base, the base overpowers the acid, making that particular solution a basic solution. So the correct answer is A. Number 15. Which of the following reactions represent the hydrolysis of alkanoates? Alkanoates. Alkanoates is an alkane family. Alkanoates is an alkane family. Alright? The hydrolysis of alkanate is the reaction of an alkanate with water to form carboxylic acid and alcohol. Carboxylic acid and alcohol. So I said the hydrolysis of alkanoate is the reaction of an alkanoate with water to form carboxylic acid and alcohol. Carboxylic acid and alcohol. Now, checking at A, B. Carboxylic acid is CH subscript 3, COO subscript 2, COOC subscript 2, H subscript 5. That is carboxylic acid. Alright, so the carboxylic acid is reacting with water, okay, to give you the alkali, is reacting with water to give you carboxylic acid and alcohol. Carboxylic acid and alcohol. So the alkanate, which is the CH subscript 3, COO, C subscript 2, H subscript 5, which is the alkanate, reacting with water. Alright? Now, it produces carboxylic acid. Produces carboxylic acid and alcohol. So that means, checking out these equations, the correct answer is B. CH subscript 3, COOC subscript 2, H subscript 5, reacting with water to produce CH subscript 3, COO plus CH subscript 3, CH subscript 2, and OH. The OH identifies that it is an alcohol. OH identifies alkanol, which is an alcohol. Number 16. Which of the following statements about the collision theory is correct? Which of the following statements about the collision theory is correct? They said all collision brings about reaction. No. All collision does not bring about a reaction. The rate of reaction is proportional to the number of effective collision. Yes. Collision of molecules will split the molecules to react. Ineffective collision brings about chemical reaction. No. Now, all collision brings about reactions. Not all collision brings reaction. Not all collision brings reaction. Now, take for example, if hydrogen and hydrogen collides, it does not bring a reaction. Why? Because a reaction leads to the transformation of certain substances to another. That means it deals with different substances, not the same substance. So if hydrogen and hydrogen reacts, let's say H, right? Let's say hydrogen reacting with hydrogen will give you H subscript 2. This cannot be a form of reaction because every reaction leads to a compound. And this cannot be a compound because it consists of atoms of the same element. It consists of atoms of the same element. So that means all collision do not bring about reaction. Now the rate of reaction is proportional to the number of effective collision. Yes. As the molecules collide, the more they collide, the more the rate of reaction is increasing. The more they collide, the more the rate of reaction is what? Increasing. So the correct answer is B. Let's go to the next one, number 17. Why are sulfuric acid, which is known as tetraoxosulfur 6 acid, and calcium chloride not suitable for drying ammonia gas? Why are sulfuric acid, tetraoxosulfur 6 acid, and calcium chloride not suitable for drying ammonia gas? For drying ammonia gas is because, not because they are corrosive, right? Not because they are corrosive. Calcium chloride is not really corrosive, so both of them are not corrosive. Not because they are poisonous, but because these acids react with gases. They react with gases. So when ammonia gas, okay, is being contacted with them, they cannot dry it because there must have to be a reaction. There must have to be a reaction. So since these acids react with gases, they cannot dry any substance that is gaseous. When they come in contact with gaseous substance, they have to react because they react with gases. So the correct answer is C. Number 18, which of the following equation does not illustrate correctly one reaction of chlorine? Which of the following illustration does not illustrate correctly one reaction of chlorine? Now, looking at these equations, you see hydrogen sulfide reacting with chlorine to give you 2 hydrochloric acid and sulfide. Yes, that's the balanced equation, that is correct. Alright, Cl subscript 2 reacting with sodium hydroxide to give you sodium chloride and sodium chloride oxide plus water. Sodium chloride oxide plus water. The next one says chlorine reacting with sodium fluoride to give you sodium chloride and fluorine. Sodium chloride and fluorine. Checking at C, you see that C is definitely not a reaction between chlorine. C is definitely not a reaction for chlorine. C is not a reaction for chlorine. Why? Because fluorine and chlorine are both non-metals. Fluorine and chlorine are both non-metals. So the reaction there will not be ionic. The reaction will not be ionic. Now, the chlorine reaction definitely collides with metals. Chlorine reaction definitely collides with metals. Now, it reacts with hydrogen because hydrogen basically reacts with metals, non-metals, and metabolites. Okay, when hydrogen reacts with metals, it gives out is negative. When hydrogen reacts with non-metals, it gives out is positive. So that means hydrogen is friendly in reacting with metals and non-metals. So chlorine can definitely react with them. But chlorine do not have the tendency or the strength to react with non-metals with him. Don't have the strength to react with non-metals with him. Now coming to fluorine, fluorine do not react with chlorine. So the correct answer is C. Number 19, how many unpaired electrons are present in this? Now 26, that down one becomes the atomic number. The up one becomes the mass number. The down number is the atomic number, while the superscript, the up number, is identified as the mass number. But in this context, they are telling us how many unpaired electrons are present in ion ions, in ion trications, in ion trications. Now, when you see something like this, 3 plus, this one up represents the ion, that means it represents the charge. It represents the charge. So they say how many unpaired electrons are present in ion
trications. Ion trications. The correct answer is 5. They have 5 unpaired electrons. The correct answer is D. Number 20, going down group 2 in the periodic table normally. Going down the group 2 in the periodic table normally, melting point increases. Okay, shielding effect decreases, melting point increases, ionization energy increases, electronegativity increases. Now, ionization energy is the energy required to remove an electron from an isolated atom that can be shared to another atom. Right? Ionization energy is energy required to remove an electron from an isolated atom. Now, when they say going down the group 2 are the alkaline earth metals. That means as the atomic number of the metals are increasing, their melting point is increasing. As the atomic number of the metals are increasing, their melting point is what? Increasing. So when you say the group 2 elements, the group 2 are the alkaline earth metals. So that means the group 2 are metals, alkaline earth metals. So as it is increasing, their melting point will be increasing. So the correct answer is B. 21. Which of the following elements has its valence electrons in the s orbital? Which of the following elements has its valence electrons in the s orbitals? The s orbital is sodium. Sodium has its element in the s orbital. Sodium has an atomic number of 11 and a mass number of 23. So that means it has its valence electrons in the s orbital. So the correct answer is A, sodium. Now, 22. The periodic property that is used to determine whether a covalent molecule is polar or not is a polar element. So a polar molecule or compound is a compound that has electronegativities. When I mean electronegativities, it has a positive and what? A negative. It has a positive and a negative. The compound is formed between a positive ion or a positive metal and a negative non-metal. So that means electronegativity is the measure of the ability of an atom to attract electrons in a chemical bond. Electronegativity is the measure of the ability of an atom to attract electrons in a chemical bond. So that means this particular attract electrons in a chemical bond. So if, for example, two non-metals come together, all right, let's say S and O, for example, two non-metals come together, they give you sulfur oxide. There is no electronegativity, there is no attraction of electrons, as both of them are donors. They are donors. Both of them are acceptors, They are acceptors, they do not donate. They are non-metals. Non-metals readily forms negative ions by accepting electrons. Alright, while the metals readily forms positive ions and they have metallic bonds. That means they give out. Proton is for donating, electron is for accepting. Just like the acid being a proton donor. So the electronegativity becomes the measure, alright, of an atom to have the ability to attract electrons in a chemical bond. Chemical bond in the sense that the chemical bond talks about the reaction, either covalent, electrovalent, or anything. So this comes, let's say hydrogen and chlorine will form a polar. Because the hydrogen, like I said, gives out is positive. In essence, the hydrogen becomes a donor when reacting with non-metals. Then, when reacting with metals, it becomes an acceptor. So that means this hydrogen has a negative charge from chlorine. So the hydrogen becomes a positive and the chlorine becomes a negative. So now the chlorine accepts from the hydrogen. That makes it a polar molecule, a polar compound. So the correct answer is C, electronegativity. 23. The following steps are scientific methods except. Now, scientists are people that go into researches in a particular area. They are broad, right? They are broad in problem solving. They do not think of the problem, they think of the solution. In essence, they first of all identify the problem. Okay, that thereby collecting the problem. Put the problem into experimentation. After the experimentation, they analyze the problem and gives the solution. They take the problem, experiment the problem by organizing it. Then they analyze it, present it, and give a solution. Just like statistics in mathematics. There's statistics the process of collecting, organizing, presenting, analyzing of information or data. That's the same thing. Okay, so they analyze a problem, they experiment a problem, they identify the problem, they just identify the problem. They don't think of the problem, they identify the problem and think of the solution. Alright, so the A, they analyze a problem, they experiment a problem, they identify a problem. Because before they solve a problem, that problem must have to be identified. When they identify the problem, you put it through experimentation. It's like an hypothesis. You put it through experimentation. Then from the experimentation, the facts you get is being used to analyze the experimentation for you to make it a law. So they analyze, they experiment, they identify, there is no open-mindedness. So the correct answer is B. 24. Isoelectron species have the same number of electrons. Isoelectron species have the same number of electrons. Okay, the word isoelectronic species have the same number of electrons. Okay, isoelectronic species are when the protons change to an electron. Isoelectrons is when the proton change to an electron. So they must have the same number of electrons. The correct answer is A. Number 25. An element X has two isotopes. Isotopes are elements that have the same atomic number but different mass number. And I told you that the number down identifies the atomic number, the number up identifies the mass number. Now if you check, they have two different mass numbers, but they have the same atomic number. Okay? Now they said an element X has two isotopes, this and this, a subscript of 30 and superscript of 65, and subscript of 30 and superscript of 66. With the relative abundance of 60% and 40% respectively. The relative atomic mass of the X is, when they say mass, we'll find the abundance of the first isotope, find the abundance of the second isotope, then add both of them together. That is a mass. Now, abundance, we'll know the difference between the first isotope. Difference between the first isotope. That means you are going to know the difference between the mass number and the atomic number. Then you times it by the percentage. You're going to know the difference between the mass number and the atomic number of the first isotope, then times it by the percentage they give to you. Now the first one says with the abundance of 60 and 40. That means the first one is 60 and the second is 40. So the first isotope is the difference is 65 minus 30. 65 minus 30, which is equals to 35. Okay? The relative abundance is 60%. So 60% is 60 over 100. So therefore, first isotope is equals to 35 times 60 divided by 100, which is equals to, let's check, 35 times 60 divided by 100 is equal to 21. So the first isotope is 21. Now, second isotope. You're going to note the difference again. 66 minus 30. 66 minus 30. Because the mass number is bigger than the atomic number. What do I mean? The mass number is the number of protons and neutrons together, while the atomic number is the number of protons alone. So something is added to the proton to give you the mass number. Right? So that means if the atomic number is 30 and the mass number is 65, then what is added to that is 35. That was added to it. So the 35 becomes the number of neutrons. Same here is 36 equals to 36. Now, relative abundance of the second is equals to 40%. So therefore, second isotope is equals to 36 times 40 over 100, which is equals to, let's check, 36 times 40 divided by 100 gave us 14.4. 14.4. Now, the first one is 21. All right? The first one is 21. Then the second one is 14.4. Okay, first one is 36. Second one is 14.4. All right? Now, adding 36 and 14.4, therefore it will be equals to 36 plus 14.4. 36 plus 14.4 will give you 65.4. So the correct answer is B. So the correct answer is B. Okay. 36 times 100. Okay. 36 times 40. 36 times 40 divided by 100 is 14. So the correct answer is 65.4. So when you add the two isotopes, first and second isotopes, you'll get the correct answer as 65.4. 65.4. So let's go to the next question. The next question is, the pair of compounds that belong to the same homogeneous series is, when they say homogeneous series, they're trying to talk about the same family. Alright, trying to talk about the same family. So the first one is an alkyne family and an alkane family. The second one is an alkane family and an alkyne family. The third one is an alkane family and an alkyne family. The fourth one is an alkane family and alkane family. Alright? So the first one, the C subscript 2, A subscript 6 is ethane, and C subscript 4, A subscript 10 is butane. So they have the same family. They come from the same family, which is the alkane family. So the correct answer is D. So a consequence of global warming is, when you say global warming, what causes global warming? That's a simple thing, flooding. Flooding is what causes global warming. The correct answer is A.
Okay, number 28 says, which of the following gases has the lowest rate of diffusion? Okay, this is the Graham's law. According to the Graham's law, it tells us that the gas with the highest mass diffuse slowly. So the rate of diffusion of a gas is inversely proportional to its vapor density. The rate of diffusion of a gas is inversely proportional to its vapor density. That means it is not equal to the density of the gas. So the diffusion of the gas is not equal to the density of the gas. Density is mass per unit volume. The amount of mass and the volume it occupies. So the highest, the heaviest gas will diffuse slowly. The heaviest gas will diffuse slowly. The lightest gas will diffuse more vigorously. So the rate of diffusion of a gas is inversely to the vapor density. So it is not equal to the rate of their diffusion. So that means it is opposite. Okay, the heavier gas diffuse slowly. The lighter gas diffuse fast. So looking at the molecular masses, they've given you the molecular masses according to their grams and mass. So it said hydrogen is 1.0, that means it's 1. Carbon is 12.0. Nitrogen is 14. Oxygen is 16. So the heaviest gas there is oxygen, which is 16. So it's going to diffuse slowly. So the correct answer is oxygen. Correct answer is C. Going to 29, the gas that is less dense than air is, the gas that is less dense than air is, the gas that is less dense than air is carbon dioxide, carbon 4 oxide, which is carbon dioxide, nitrogen, chlorine, and oxygen. Now, carbon dioxide is heavy. Okay, it comprises of two gases. All right, chlorine and oxygen. When you say less dense than air, it means it has a lower mass than air. That's what it means. It means it has a lower mass than air. All right, so carbon dioxide is heavy, comprises of two gases, which is carbon and oxygen. Chlorine is heavy. We know that it has two isotopes, 35.5 and 37. Oxygen is 16, is heavy. So the lowest there is nitrogen. So the lowest gas is less dense than air. So carbon dioxide is high. Chlorine is high, 17. Oxygen is 16. So the lowest gas becomes less dense than air, which is nitrogen. So nitrogen has 14. So the lowest gas there is 14, which is nitrogen. Nitrogen has the mass number of 14, atomic number of 7. All right, chlorine has an atomic number of 17. Oxygen has an atomic number of 8. So their molecular masses are increased. So as they're increasing, that is how they are heavier than air. So the correct answer is B, nitrogen. Number 30. Which of the following equimolar solutions has the highest conductivity? Which of the following equimolar solutions has the highest conductivity? Now, equimolar means equal in molar solution. Equimolar means equal. Equimolar means equal. Now, if you check, the first one, H subscript 2, CO subscript 3, which is hydrogen carbonate, is not equal. That solution is not equal. The second one is sulfuric acid. All right? What does it mean? That when you put this substance in water, it dissolves permanently. When you put this substance in water, it gives an equal range of water and the substance. Now, what donates to water is an acid. And if you check which one is an acid there, hydrochloric acid or sulfuric acid is the one that donates to water. According to Arrhenius, he said an acid is a species that donates proton to water. So that means what is donating to water? What do have an equal mass when it enters into water? Which of the substance dissociates in water completely that will produce something to water? Sodium hydroxide dissociates in water completely, yes, but it does not donate to water. Rather, it accepts from water. So the correct answer is B, sulfuric acid, when being put in water. This AQ here represents an aqueous solution. Aqueous means the solvent is water. The solution is made up of water. So the correct answer is B, sulfuric acid. 31. What takes place at the cathode during electrolysis? What takes place at the cathode during electrolysis? When I say electrolysis, electrolysis is simply the flow of electrons. Electrolysis is simply the flow of electrons. All right, so as electrons are flowing, it is the protons that do flow. I told you that the protons give. When I say proton, proton means a giver, a donor. All right, then electron means what? An acceptor. So when the flow of electrons is being given, it is the proton that charges the electron. Why? Because the proton is 1 million times electrically charged than the electron and 1,084 times heavier than the electron. So when you give out, when the anions are electrons, a type of electrons, all right? Anions are type of an ion with a negative charge. So that means the anions are electrons, the cations are protons. The cations are a type of protons with a positive charge. Now, when the flow of electrons happens, the cations give to the anions. In essence, the proton gives to the electrons. All right? So as the cations are giving, they are discharging. And the cations are giving, they are discharging. So as the flow is happening, which electrolysis, like I said, electro means electrons. Lysis means flow of electrons. So as the electrons are flowing, it is the protons that give to the electrons. So in essence, the cations, which are the protons, must have to give to the electrons. So that means in this question, what takes place in the cathode during electrolysis, the cations are what? Discharged. A cathode is a positive area. The anode is a negative area. Now, in the cathode must have to emit for the anode to receive. So the cations is being discharged for the anions to receive. So the correct answer is C, cations are discharged. Number 32, how many grams of sodium hydroxide will be needed to produce 100 centimeter cube of 0.2 mole decimeter cube? Sodium hydroxide in aqueous solution. Sodium hydroxide is 40. Sodium hydroxide is 40. It's a simple thing. All right? When they say mole decimeter cube, I think that is a 1,000 centimeter cube. Okay? That should be 10, that should be 10 centimeter make 1 decimeter. So that means this 100 centimeter will be times 1,000. So converting the decimeter to centimeter is going to be 100 divided by 1,000. Converting this decimeter to centimeter is going to be 100 divided by 1,000. Okay, so in a simple mathematics, we will say 0.020. It's same as 0.2, sorry. 0.20 is still the same thing as 0.2. 0.20 is the same thing as 0.2. 0.30 is the same thing as 0.3. But let's just put 0.20 times 100 divided by 1,000. Because you must have to convert this 100 centimeter to decimeter first. Because what you're working with, they said how many grams of this will be produced, will be needed to produce this of 0.20 moles decimeter cube. That means how many centimeter, how many grams will be needed to produce 100 centimeter of 0.20 mole decimeter cube. So that means what you're looking for is how many in centimeter that will produce in a decimeter. So that means you're converting the decimeter cube to centimeter cube first. So even if you want to convert, you can still say 0.20 times 100 over 1,000. You see the same thing? Okay, 0.20 times 100 divided by 1,000 is giving you 0.02 is equal to 0.02. Now you times it by the molar mass times 40. I think that should be 0.8 grams. It should be 0.8 grams. I come again. They said how many grams of sodium hydroxide solid would be needed to produce 100 centimeter cube of a 0.20 mole decimeter cube sodium hydroxide aqueous. That means taking the sodium hydroxide into water, making it to dissolve in water. And they gave it a mass number of sodium hydroxide as 40. Now, you convert, first of all, you convert that to decimeter. When you convert it to decimeter, you now times it by the number they gave to you. When you times it by the number they gave to you, that's how we get 0.20 times 100 over 1,000. This 100 over 1,000 is converting centimeter to decimeter. Now, when you convert this to decimeter and times it by 0.20, it's going to give you 0.02. When you convert this to decimeter and times it by 0.20, it's going to give you 0.02. Okay, let's do the second one. Let's see if we can get the same answer. Now, changing centimeter to decimeter first is 100 divided by 1,000. 100 divided 1,000. 0.1. 0.1. So now you have gotten this in decimeter. Now, times it by the number of moles they gave to you. It will be 0.1 times 0.20. All right? Will be equal to times 0.2. 0.02. Then you now times it by the mass number times 40. It will still give you 0.8 grams. So the correct answer is 0.8 grams. The correct answer is B, 0.8 grams. The formation of a bond between hydrogen and highly electronegative atom results in, I think we just talked about this before now. Metallic bonds are bonds that exist between metals. Okay, dipole talks about negative poles, all right? Electrovalent bonds are bonds that exist between metals and non-metals, also termed ionic bond. Okay, it talks about the transfer of electrons. Okay, unlike the covalent that talks about the sharing, this talks about the transfer of electrons. Now, I said a polar compound is a compound that consists of electronegativities, positive and what? Negative. So the formation of a bond between hydrogen and a highly electronegative atom results in, I told you before now that when hydrogen is reacting with a negative atom or a negative metal, it gives out is positive. That means the hydrogen will be positive and the metal, let's take X as the substance, becomes negative. This forms a polar compound. That's because this compound consists of both positive and what? Negative. So the correct answer will be polarity, because the polar compound consists of electronegatives. So the correct answer is A, polarity. 34. The molecule that has a non-polar covalent bond is, okay, the molecule that has a non-polar covalent bond is hydrogen and oxygen, hydrogen and chlorine, hydrogen and nitrogen and hydrogen, chlorine. Now, if you check, a bond must have to consist of two elements. Must have to consist of two elements, first of all. You have to clear that first. When they say bond, the chemical bond leads to a chemical reaction. And that reaction leads to a chemical transformation. So the type of bond tells us the type of compound it's going to form. So a bond, first of all, must have to do with two substances. That's number one. As I said that, I know that you've already seen the answer, because there is one that does not have two substances. All right? So that bond must have to deal with two different substances, not substances of the same element, two different atoms. Now, that's number one. Now, number two, a non-polar covalent bond. So they say the molecule that has a non-polar covalent bond. All right? That means which of them is not polar. We just talked about a polar in number 33. I told you the hydrogen reacts with all of them. So that means all those compounds hydrogen is reacting with a non-metal is a polar compound. Are all polar compounds. So the molecule that has a non-polar, which one is non-polar? Because all are polar. Because it has to do with hydrogen reacting with other metals. Now, the bond that exists between hydrogen and non-metals is the hydrogen bond. Hydrogen bond is a bond that exists between hydrogen and non-metals. But the type of compound it forms is a polar compound. Because hydrogen, being versatile, gives out its negative when it's reacting with non-metals. In essence, making the compound a polar compound. Because the polar compound consists of electronegatives. Negative charges, positive and negative. So looking at that, first of all, the bond there must have to do with two elements. And secondly, hydrogen reacting with any non-metal produces a polar bond. So the correct answer is C, chlorine. 35. Which of the elements in the table below will react more readily with chlorine? Which of the following in the table below will react more readily with chlorine? Now, annihilation energy, the energy required to remove an electron from an isolated atom. To remove an electron from an isolated atom. Now, the energy required to remove an electron from an isolated atom. Now, the annihilation energy is telling you that W is small, X is small, Y is bigger, and Z is bigger. So which of them can react readily with chlorine? Which of them can react readily with chlorine? Now, Checking at the W and X, 12 is carbon, first of all. So that means you need 12 moles to remove 12 electrons from carbon. All right? So looking at the table, you will see that the first one is smaller. The second one is smaller. The third one is big, and the last one is biggest, is bigger. So that means any element that can react with chlorine must have to have a lower ionization energy. An element that has to react with chlorine must have to have a lower ionization energy. What do I mean? It must have to be lower than the mass number of chlorine. Take for example, if I say, which of the elements below will react readily with sulfur now? All right? The ionization energy must be lower than that of sulfur. Must be lower than that of sulfur. So chlorine has a mass number of 35.5. Which of them is lower than 35.5? That is the answer you're supposed to use. Which of these is lower than 35.5? Which of the ionization energy is lower than 35.5? Because for me to react with another element, my ionization energy must be lower than the element I'm reacting with. So now they brought chlorine. Chlorine must have to react with an element that he is higher than, so that it can be able to react comfortably with. If they tell you sulfur, sulfur have to react with an element that he is higher than. The ionization energy is the energy required to remove that electron, to remove that breakage of bond, to bring out the electron, so that there must have to be a reaction. To remove the valence electron that can be transferred to another atom. So that means the chlorine is 35. Which of them is lower than 35? That's how you look. So any element they give to you, in case you see this question with another element, you look at the mass number of the element first. Now, which of the ionization energy is lower than the mass number of that element becomes the answer. So if you check W is lower than 35.5, 21 lower than 35.5, 106 is higher, 200 is higher. So the answer is W and X only, because they are lower than the mass number of chlorine, 35. So the correct answer is A. The next one, the relative molar mass of gaseous hydrocarbon is 30. Determine the vapor density. It's a very simple one. Vapor density is dividing the element by hydrogen. That's all. Vapor density is dividing the element by hydrogen. So if the hydrocarbon is 30 divided by hydrogen, hydrogen has a molecule of 2. This is a molecule of hydrogen, H2. So that means vapor density is dividing the compound or the element by 2. So that means it is 30 divided by 2, which is what? 15. So the correct answer is 15. When they give vapor density, if they give you the molar mass of an object, say find the vapor density, just divide that molar mass by 2. That is vapor density. So the correct answer is 15. The next one is consider the following reaction equation. Which of the following statements about the reaction is correct? The following statement about the reaction is correct. Okay? The reaction is correct. Now, look at the reaction very well. Look at the reaction very well. Consider the following reaction. Now, this is the reaction they gave to you. 2SO3 gas gives you 2SO, 2SO2 gas plus O. 2 gas, okay, gas. Then there's a change okay, plus 198 kilojoule. 198 kilojoule mole. 198 kilojoule per mole. Now, looking at this reaction, the reaction is a very simple reaction. Which of the following statements about the reaction is correct? Now, they say the reaction is exothermic. The reaction container would feel warm. 198 kilojoule of energy is given off. 198 kilojoule of energy is absorbed. 198 kilojoule of energy is absorbed. Now, there is a change of heat. This is the direction of the reaction, and this is the direction. So that means the rate of forward reaction equals the rate of backward reaction. That's what it means. All right? When you see a sign like this, it means the rate of forward reaction equals the rate of backward reaction. That means this is equal to this. That's what it means. This is equal to this. That means there is an equilibrium. Now, if you look at the reaction, all right, heat, this heat, there's a change in heat. Change. There's a change in heat. So that means the equation stored. The equation stored heat, this 198 kilojoule mole, for this reaction to occur. The heat is equal to this. That means the heat they used is this for this reaction to occur. That's what it means. So if you look at A and C, they are the same thing. When they say the reaction is exothermic, that means they're talking about the system lose heat. And 198 kilojoule of energy is given off. That means they're trying to tell you that 198 kilojoule of energy was used as the exothermic process, given off. Now, if you check, this is the reaction. All right? In case you see this next time, when you see the reaction like this, come down and look at the heat. But first of all, concentrate on this. Concentrate on this. If this gives a reaction, if this gives an equilibrium of arrow front and back, that means it is an equilibrium. But if it gives like this alone, that means it is given out. All right? So now, looking at the reaction, you see that the heat that was absorbed for this reaction is 198 kilojoule per mole. So now, for the heat to be used as a reaction, that heat must first of all be stored. For example, if I put a pot on the fire, all right, and I put water inside, for the water to get boiled or to get hot, the pot must first of all absorb the heat before it can transfer the heat to the water. So the amount of heat that is being absorbed will be the amount of heat that the pot can send to the water. So the amount of heat that was absorbed here was used for the reaction. So that means 198 kilojoule per mole of heat, of energy, was absorbed for this reaction. So in chemical reaction, heat is absorbed, not released. So this is a chemical reaction. So heat is absorbed, not what? Released. Because a high level of heat is needed for the reaction. So the correct answer is D. 198 kilojoule of energy is absorbed. 38. Which of the following properties does not give evidence of the kinetic theory of matter? Now, when they say kinetic theory of matter is a microscopic description of matter. Kinetic theory of matter is a microscopic description of matter. It talks about the particles of matter. That's why kinetic theory states that matter is made up of very small, tiny particles that are continually moving. Now, why are they continually moving? Because they possess kinetic energy. How do they possess kinetic energy? From heat. Heat is the energy. Now, where do the particles move? Evaporation talks about the change of liquid to gas. Now, for a change to occur, particles must have to move from one place to another. Now, that means to say the kinetic theory, the evaporation becomes an evidence because it talks about kinetic theory of matter. Movement. Kinetic is movement. Movement theory of matter. Now, how do matter move? Matter move through their particles. Matter move through their particles. Now, evaporation talks about a movement of liquid particles to gas particles. So as heat is added, as heat is increasing or pressure is increasing, temperature is increasing. Now, why is the temperature increasing? Because the kinetic movement or the kinetic energy of the particles is increasing. So it is a kinetic movement, it's a kinetic energy of the particles that tells the increase in temperature. So as they are moving, the temperature is what? Increasing. As their movement is increasing, the temperature is increasing. So evaporation tells you that the liquid is changed to gas. So there is a phase transition. There is a movement of liquid to gas. So it talks about movement. Now, diffusion talks about higher concentration to a lower concentration. So there is a movement of particles from high concentration to low concentration. So that means they started high, so their movement starts getting slower as heat is being removed gradually. Remember, when heat is added to a substance, it becomes hot. When heat is removed, it becomes cold. So heat causes both hot and cold. Now, polymerization is a process which small molecules combine to form larger molecules. It's a process which small molecules combine to form larger molecules. So they just combine to form. There's no movement. They came, combined, okay, and they formed something. Just like the elements combined in forming a stagnant thing, a compound. Now, melting, there is a phase transition of solid to liquid. Solid to liquid. Now, the heat gained in melting is used to separate the molecules. So, therefore, the correct answer is C, polymerization. Particles coming together, clinching, stay in that place to form a larger molecule. So, the correct answer is B, polymerization. 39. A compound that could be dried by using concentrated tetraoxosulfur-6 acid and not by calcium oxide is likely to be an acid anhydride. First of all, an alkaline gas, a neutral salt, a deliquescent salt, an acid anhydride. An acid anhydride are acids that react with water. Okay? Anhydride are acid that reacts with water to form acids. This acid reacts with water to form acids. What do I mean? You can dilute them and they will still form acid. So a compound that could be dried by using concentrated tetraoxosulfuric acid and not by calcium oxide is likely to be an acid anhydride. So the correct answer is D. Why? Because tetraoxosulfur-6 acid reacts with water to produce acid. So that is why the answer is D. So the correct answer is D. Number 40, positive ions in the sea of electrons. Positive ions in the sea of electrons. Positive ions in the sea of electrons are found in covalent bonds. Dative bonds are still covalent. Right? Dative bonds are still covalent. Now, covalent bonds is the mutual sharing of atoms, is the mutual sharing of electrons between atoms and molecules. So that means atoms and molecules are electrically neutral. All right? So there's the sharing of electrons. And covalent bonds talks about non-metals because the non-metal possess no positive charge. So that means the covalent bonds is the sharing of electrons between non-metals and non-metals. That means between non-metals, a non-metal and a non-metal. So the positive ions cannot be seen in a covalent bond because it is a non-metal. A dative bond is still covalent. It's still covalent. Now, ionic bonds is between a metal and a non-metal. In essence, between positive and negative species. So positive ions are not being seen there because in ionic bonds, you transfer electrons. Electrons are not shared, they transfer. So the positive gives to the negative. And what they form is negative. For example, if I say sodium reacting with chlorine will give me sodium chloride. This is plus, this is minus, plus minus. Now this sodium is plus because the sodium is a metal. So every metal are electropositive and they are good conductors. Quite all right. They conduct electricity because they are electropositive. While the non-metals are electronegative. They are poor conductors. So now, why do they give out a negative compound? Because this sodium, for example, has 11 protons. That's because the atomic number of sodium is 11. This sodium has 11 protons. Now, if sodium has 11 protons, that means it still has 11 electrons. Because the number of protons quantify the number of electrons. All right? So if a substance has 5 protons, then that means it has 5 electrons. Okay? So the number of protons is 11, that means the number of electrons is 11. Now, the sodium gives 11 electrons to chlorine because the sodium is a donor, while the chlorine is an acceptor. Sodium is a metal, is a donor. He donates electrons. The chlorine accepts electrons. Now, if he gives out 11 electrons to chlorine, it's going to have 11. If he gives out 11 protons to chlorine, it's going to have 11 what? Electrons. That means electron now will react to electron to produce an electron. If he gives out his 11 protons, what remains with him is 11 electrons. So he becomes negative in that context. Why in the metallic bond is between a metal and a metal. So in that place, you find the positive ions in that area. Because a metal is positive, the metals are positive. I told you that a metal is an element that readily forms positive ions and have metallic bonds. So the correct answer is D, metallic bonds. 41. Dilute trioxynitrate 5 acid does not produce hydrogen when it reacts with metals because dilute trioxynitrate 5 acid does not react does not produce hydrogen when reacts with metals because now we know that acid when reacts with metal produces hydrogen. So if an acid reacts with metal and does not produce hydrogen, then it's an oxidizing agent. Acid, one of the characteristics is that when they react with metal, they produce hydrogen. That's one of the characteristics. Because every acid has hydrogen. Okay? So, except the sulfur oxide that does not have hydrogen. So when the acid reacts with metals, they produce hydrogen. So any acid that do not produce hydrogen becomes an oxidizing agent. All right? An oxidizing agent becomes an agent that produces oxygen. Since it's not a reducing agent, it's an oxidizing agent. So if it does not reduce, it's going to produce. So your reducing is hydrogen. Because in hydrogen, the oxidizing agent becomes the loss of electrons, while the reduction becomes the gain of electrons in hydrogen. So if it does not produce hydrogen, then he is not reducing. That means he is not gaining electrons. He is losing electrons. All right? Why normally oxidation is the gain of electrons or the gain of oxygen, while reduction is the loss of electrons or the loss of oxygen. But in hydrogen, oxidation is the gain, is the loss of electrons in hydrogen, and reduction becomes the gain. So if an acid reacts with a metal, it becomes a loss to him. So it becomes, it's a reduction because he's losing hydrogen when it reacts with metal. But when a metal reacts with an acid and gains hydrogen, then he is an oxidizing agent. So in that context, A is the correct answer because he's a strong oxidizing agent. The correct answer is A. Number 42. How many moles are there in this? How many moles are there in 30 grams of oxygen molecule? Knowing fully well that O is 16. So let's see how many moles are there. O is 16. So O is 16. All right, so the number of moles of oxygen, number of moles of oxygen is equals to 16. Is 16. So therefore, number of moles of oxygen gas is 16 times 2. Okay, the mass number times the subscript will give us what? 32, first of all. Now, they say how many moles are there in 30 grams. So, moles in 30 grams, moles in grams will be equals to 3.0 over 30. So, let's do the calculation. 3 divided by 30 is 0.1. Is equals to 0.1. Now, if you check, the nearest answer is 0.0930. So 0.09 is approximately 0.1. 0.09 is approximately 0.1. So the correct answer is B. The answer is 0.1. Well, 0.09 is approximately 0.1. So the correct answer is B. Copper 2 ions are able to participate in coordinate covalent bonding because copper 2 ions are able to participate in coordinate covalent bonding because they can accept pair of electrons from donor atoms. They can accept pair of electrons from donor atoms. Now, the orbitals of D, they have vacant D orbitals. Now, these orbitals in D accept electrons from donor atoms. The orbitals in D accept valence electrons from pair of electrons from donor atoms. So the correct answer is C, have vacant D orbital. 44, determine the volume of this in this. That means determine the volume of 0.100 mole of hydrochloric acid in 0.250 mole decimeter cube of solution. It's just a simple thing now. To solve this is mole divided by volume times 100. Mole divided by volume times 100. Now, the mole divided by the volume. The mole divided by the volume times 1,000. What do I mean? Decimeter cube, mole divided by the volume times 1,000. Decimeter cube, when you see decimeter cube, it must have to be 1,000. So it is mole, determine the volume. The volume will be equals to mole over volume times 1,000. All right? Mole over volume times 1,000. So that means the mole is 100 divided by the volume. The mole is 0.250 divided by the volume, which is 100 times 1,000. So it will be 0.250 divided by 100 times 1,000. So let's see, 0.250 times 1,000. 0.250 times 1,000 divided by 100. The calculator. Times 0.250. So when you get this, the correct answer is D, 400 centimeter cube. The next one says, correct answer is which of the statement about gases is not correct? The total kinetic energy of gas is not affected by collision. Molecules of a gas are in constant motion. Gas have low densities compared to solids and liquid of equal mass. Gases are highly soluble in water at high temperature. Now, if you look at the kinetic theory of gases, you will see that the total kinetic energy of a gas is not affected by collision. Okay? Not because the gas molecules, as they collide, they go and go anywhere they can. They hit the walls of their container. All right? So as they are being put in a container, they expand to fill their container. So because they have high kinetic energy, they go wherever they can. So when they collide, their kinetic energy is not being affected. Okay? When they collide, they go back because they don't even collide. Kinetic energy of gases do not even collide because they escape vigorously. They have spaces in them, so there's no collision. So the A is not the correct answer. So molecules of a gas are in constant motion, yes. Because the particles of matter have kinetic energy, they are in constant motion. So the molecules of gases are in constant motion. Gases have low densities compared to solids and liquids, yes. Because gases have no definite mass, as well as no definite mass, no definite volume, and no definite shape. Now, the solids and liquids are more heavier than gases. All right, because there is a space in them. They have spaces in their molecules. Now, gases are highly soluble in water at high temperature. Gases are not soluble in water at high temperature. They are not soluble. Okay, gases mostly react at low temperatures. So the correct answer is D. Arrange the following compounds in decreasing order of their boiling point. When order in decreasing order of their boiling point. Hydrogen fluoride, ammonia, silicon, and methane. Yes. So the correct answer is C. Hydrogen has a low boiling point, followed by ammonia, followed by silicon hydride and methane. Correct answer is C. The following statements are correct except energy is released when liquids change to solid. Particles move faster in the gaseous state than in the liquid state. Carbon atoms in gaseous methane are further apart than those in solid diamond. There is a large decrease in the volume of solid metal when pressure is applied to it. Okay, the first one says energy is released when liquid change to solid. Yes. When liquid is changing to solid, energy is released because energy is being used for the movement. I told you that the particles move. So because as they are moving, why are they moving? Because they have kinetic energy. So energy is being used, energy is being released when there's a transformation of matter. When there's a phase transition of matter, energy is used for that phase transition. Okay, so A is not. B, particles move faster in gaseous state than in liquid state. Yes, we just said that just now, that the particles of gases move randomly. They diffuse vigorously. So that means their particles have the highest kinetic energy. So they move faster than the liquids. Carbon atoms in gaseous methane are further apart than those in solid. Yes. Okay, the atoms in solid diamond have a close range. That's why they form that octahedral shape. They form that octahedral shape because they have a strong cohesive force. Their carbon is close. Diamond is known as the hardest substance in the world. So they have a strong cohesive force. Their carbon atoms are close. While that of methane is a gas, so their carbon atoms are far apart. So C is not the answer. So D says there is a large decrease in volume of solid metal when pressure is applied. No. When pressure is added, remember the solid has a metal has high melting point and high boiling point. So there's no large decrease when pressure is added because their melting point is high. So the correct answer is D. The next one says the vapor density of an organic compound with the molecular formula this is. Just add all of them now and you divide by 2. That is the answer. You know, we just did a vapor density now. So let's take them. Hydrogen is 1. Carbon is 12. And oxygen is 16. These are their masses. Now let's know their molecular masses. So carbon, hydrogen will be 1 plus 1 times 4. Because in the formula, it has 4 atoms. So it will be 1 times 4, which is 4. Carbon will be 2 times 12, which is 24. And oxygen will be 2 times 16, which is what? 32. Okay? Now, if you see a compound with a subscript, all right, for you to know the mass number, you must have to times, for you to know the molecular mass, you must have to times the mass number given to you times the subscript of that element. Subscript means the number that is at the base of the element. That small number you see, that C2 you're seeing, that H4 you're seeing, that 2 and 4 are not called C2 and C4 because it's at the base of the element. When you say 310, when you see something like this, you don't say 310, you say 3 base 10 because it's at the base of the element. In chemistry of elements, it's called a subscript because it denotes the number of atoms in that element. All right? So it has given you the number of atoms in carbon. So the number of atoms in carbon is 2. Then the mass number is 12. So for you to know the molar mass, you must have to times it by the mass number. Number of atoms times the mass number gives you the molar mass. Now, we have gotten all. I told you that vapor density is just dividing the compound by 2. You're dividing by hydrogen, and hydrogen has a molecular formula. Hydrogen has a molecule of 2, so you're dividing it by 2. Now you add the mass of the compound and divide by 2. Now this is the mass of the compound. We get 4 plus 24 plus 32. 4 plus 24 is 28 plus 32. 28 plus 32 is 60. All right? Now, this is the mass of the compound that they gave to you. Now, so therefore, Vd, which is vapor density, is 60 divided by 2, which is 30. So the correct answer is D, 30. A mixture containing 2 salts of different solubility can be separated by a mixture containing 2 salts of different solubility can be separated by chromatography forms a film. That means it separates 2 films. Distillation separates 2 miscible liquids. Okay, it removes impurities from water. Evaporation separates 2 liquids with different boiling points. That's evaporation. Crystallization. It is a separation technique that exploits different solubilities of components in a solution. Different solubilities of components in a solution. What do I mean? 2 substances that has different solubilities. All right? For example, sugar and salt can be separated by crystallization because the 2 have different solubilities. They cannot be soluble at the same time. Okay? So even if you say sand and salt can be separated by crystallization because they are not soluble. They don't have the same tendency to be soluble in water at the same time. So the correct answer is C, crystallization. Now the last says the separation technique that is suitable for separating iodine from tetrachloromethane is, you know that iodine and tetrachloromethane has a molecular formula of CCl subscript 4. All right, that means it has 4 chlorine in the methane. So tetrachloromethane is fractional distillation is used to separate crude oil. It's used for crude oil. Crude oil separation. This is not crude oil separation. Decantation is used to separate solid from liquids. Okay, liquids that can sediment, that can go down, but it's not really an accurate way of separation. Filtration, I think, separates a solid from a liquid too. All right. Now, the A talks about solvent extraction. I know it must have to be new to you. Now, the solvent extraction is still called liquid-liquid extraction. What do I mean? It removes a liquid from a liquid. The liquid-liquid extraction. Now, it's a separation technique that is being used to separate substances based on their different solubilities into immiscible liquids. Immiscible liquids are liquids that cannot mix. So what you're going to use to separate iodine from tetrachloromethane is solvent extraction, liquid-liquid extraction. Why? Because the technique is used to separate liquids that cannot mix. Liquids that cannot mix. Example, water and diesel. Okay? Diesel is a liquid, water is a liquid. All right? The diesel floats on water because it is less dense than water. So this chloromethane and iodine do not mix, so they are immiscible. Immiscible liquids are liquids that cannot mix. Miscible liquids are liquids that can mix. So the liquid-liquid extraction is a technique used to separate liquids based on their solubilities. in miscible liquids, in immiscible liquids. There are solubilities in immiscible liquids, in liquids that cannot mix. I just gave you a simple example of a clear fact, diesel and water. Okay? Diesel and water are two liquids that cannot mix. So to separate that, you use a solvent extraction. Since both liquids are solvents, every liquid is a solvent. Solvents are liquids. So the technique used to separate this is solvent extraction. So the correct answer is A. So thank you. We've come to the end of this revision. I think with this is going to help you to get an A in your forthcoming examinations.